fast.
Yeah.
You just need wind and visibility.
Right. I mean, okay. If you like it,
Yeah, of course, do what you need to do.
I don't give up all things.
all right. Good afternoon, good evening. So we have reached the last meeting for our class. And the first things first, so you have your study guide for the final. And this is going to include, where is the study guide for the final? Let's try this. I usually don't do this, but let's try. All right. So the final will be posted on Canvas, and you can take it remotely or not. On Tuesday, December 13th, so I want to make sure that everyone knows the exact time when it's open. So Tuesday the 13th, 5 to 6 p.m. Open book. Come here or not. It's up to you. And then these are the chapters that will be covered. So from chapter 6 on, functions, decisions, loops, booleans, simulation and design, classes, and for chapter 11 only lists. I'm going to talk about dictionaries today, but don't worry about them as far as the final. And how to prepare, review the lectures, code examples, and as far as the questions, we have been going through the questions in class, and I'm hoping that you kept notes, but that's what you have. So I don't want to give out the answers to the questions, but that's my suggestion how to prepare. And be careful when you read the question in case there is a trick to it. There may be some tricky wording, so don't lose points just because you didn't pay attention. All right. Questions on the final. Okay. What else? So tonight I have planned for us two different things, but with the snow, I'm not sure that we're going to make this happen. But I'm going to give you a brief lecture on dictionaries, which is another collection, unordered collection in Python. So this might be interesting. I have a video on sorting for you. You're going to like with a lot of sound effects. So let's talk about sorting algorithms in 4 minutes. And I wanted to talk about a couple of hard problems. The proof for the halting problem, which I started the course with the Turing's halting problem. So in other words, not everything is computable. And also there is another fun one, the Towers of Hanoi, which is a problem that takes so long to solve that essentially longer than the known age of the universe. But I don't know if we'll get through those. Generally, these are topics you'd cover in your next programming class anyhow. So do you have any questions? All right. If we hear anything about snow, we have to call it an evening. Am I abusing you, John?
What was that?
Am I abusing you?
No, you're not.
So, like, there's
Yes,
that.
I don't know what was the answer.
Are you watching the school alert system? What's it called? Rave?
The rave.
Oh,
It's
what-
called the rave.
No,
The rave?
The school system is called the rave. My daughter just has told me that it's not snowing in West Seattle in case. Wait, what?
Seattle. Well, I'm just gonna look up some webcams.
Thank you.
Like, just.
Yeah, don't they send to like, they text you or? It's gonna feel cold enough outside.
Well, so the sorting algorithms are part of chapter 13, but this is such a fun 4-minute video that I would like to show it to you. And I don't know what's. So we skip over this silly commercial. And so, okay. So you know that I think you're getting the idea that when you work with data, you need to do certain sorting so that the data can be accessed in an ordered manner. So sorting is a big part of computer programming. And you actually get to learn different algorithms how to sort. Some algorithms are more efficient than others, and some algorithms are more efficient than others in certain situations. This is more of a next class topic, but I thought it might be fun for you to take a look. This is a visualization that captures merge, quick, heap. Sorry. the selection, shell, insertion, merge, bubble, quick, comb, keep, and cocktail. These are just several. There are even more different types of sorts. And they're going to run in parallel, and let's just visually see here what it looks like. So this is the data that is going to get sorted, and let's see which one is going to take the shortest and the longest. You've
Yeah,
seen this.
Yeah, I saw this video. I was actually going to share it with you if you haven't seen it.
Yeah, it's pretty
Yeah,
fun.
it's
I
very
show
cool,
it often because I like it so much. Let me just make the sound because it's nice to get the sound. All right, so here we go.
There's more than one.
All right, here it is. So, as you might have seen on the previous, it's a little unclear, but the bubble sort was the slowest. It was the last one to complete, and the merge sort was the first one. But again, it depends what you're sorting. So that's an interesting, I think, topic, and you will learn in one of your other classes that you're taking actually the algorithms, how to implement this type of sorts. So that's always fun. Now for tonight, let's talk about dictionaries. So this is chapter 11.
Is there like a following class to Python 1?
I was asked this, so no, not right now. I'm trying to put together a data science in Python, which should be Python 2. If you want to learn part 2 programming class, the way this is set up right now is you take Java 1 and then Java 2 offered in
Oh, okay.
Spring.
Because it's the only one that has the sequence.
Yeah.
Oh.
And Michael, did you see my email?
Yep.
So Michael had a question. May I share it with the class? I
Yep.
think so Michael is in the web dev program. Turns out Java is a requirement. It's a required class for the web development track. So if you guys are on the web development track, I actually didn't know that. Come to my Java class next quarter. And you can take Java 1, and then in spring we have Java 2 where we're going to talk about algorithms.
So in Java 1, we'll see the same kind of concepts, but in that language.
The Java 1 will be the same concepts as Python, but in Java, and then Java 2 is more about algorithms, data structures, and so on. Yeah. All right. So let's see here. Trying to see if it's better if I don't use the screen share, but in any case. All right, so we talked about lists, and actually that's a good time to review what are lists. We talked about several characteristics of lists, such as, what is a list? Please. All right, someone start the answer, please. Christina.
Oh, stretching my
I
head.
know. Close enough.
Well, it can be numbers, or it can be what they call strings,
Okay.
separated by commas,
Okay.
and you can do things with them,
Yes.
like remove things from lists, add things to lists, substitute things from lists.
Okay. This is all correct. There are two. Yes, this is all correct. There are two other characteristics of lists that I'm looking for.
They're indexed.
They're indexed. This is the difference that I was getting at. So lists are indexed, which means that they're sequential. They're mutable. That's correct. So they're mutable, which means that you can change it, and that's at the cost of performance. And
Beautiful.
and so after lists, they are different. Sometimes you don't need to have a structure that is sequential. I think we talked a little bit about this last time. And so another very common structure is, though not as common, is the dictionary. And when you take another programming class, you're going to hear the dictionary called an associative array. Who has heard of the associative array before? All right. So associative arrays are characterized by having a key value pair. Key value pair, and then you search for the key to get to the index. So what are some examples of when we might want to use a key value pair? Well, for example, if you're looking up a student by the ID, so it's going to be the student ID and then the name. What else? Can you think of any other cases where you might use key value pairs?
Store results.
Store results. The one that I often, well, I have a couple I'm going to tell you, but can you see if anything else where it's not the order, but it's the relationship
passwords?
between
Like security.
username, password, possibly? Yes? Okay, this would be a good one. Michelle,
I'm unsure.
you can show it.
Key value. I had thought of the CID, but
I'll give you a couple and then you can maybe think of some others. So you can have a state and a state capital. Those are connected in an associative array. And the one I like is a state and a state bird. So your state of Washington has a, I don't know, is a bald eagle maybe? It has a bird. But you can also, you need an associative array to start the relationship between a state and the state bird associated with this state, right? And so you're going to hear this often. It's called a key value pair. Also, when you start working with, maybe if you're in web development with JSON, you might have JSON objects that will store key value pairs of information about the object, right? And so again, if you look at the example with the student information, student ID is going to allow you to access the student name or other information associated with the student. So we said all of these, I think. We didn't say names and phone numbers, so this one is actually pretty, we should have thought about it. Username and password, state names, and capitals. In addition to an associative array, you might also hear this type of collection referred to as a map. So maps. And so Python dictionaries are mappings, or associative arrays, or sometimes also called hashes. So when you create them, what does this look like? Well, they're going to be joined with a column. And we actually talked about this with John. I think you encountered it somewhere.
A little bit.
A little bit. So here's one example that you can try right now in the shell. You don't need to start the file. And this is how you create your first dictionary. This is a dictionary for a password. And then all the syntax. So it's curly braces. And then the key, column, the value. And what is interesting is the keys can be any type of immutable object. So they can be index numbers or strings, whereas the value can be anything. Yeah. So I'd like you to try creating an associative array. I was going to say a dictionary in Python, such as this one. And then you can also access as an index the password for Guido, except the index is not going to be 0, 1, 2 sequential, but it's going to be the index for this particular, the key for this particular pair. So would you like to try this in your shell? Something else we're going to try, you'll notice that if you display the dictionary the next time, it actually doesn't look the same sequence. It's because Python stores them internally in the way that it finds efficient. So it will not even be returned in the same sequence as you put it in. Capturing the screen. Oh. Apparently it just started snowing in USA. No.
I know, it's not, that's, I find that weird.
Okay, so let's move on. Let's move along. Did you try printing out with the index of a certain element? All right. So, for example, if you use the syntax dictionary of a key, it's going to return an object with the associated key. And as I mentioned already, dictionaries are mutable, which means that if you have a password with index of Bill and assign it blue screen, is going to change it, right? And then if you wanted to print a dictionary, that's one thing you might want to do right now, since you already have one there. Just give it a name, and then just take a look and see how the order is not going to be the same anymore. Right? And while you're trying this, to recap again, mappings are unordered, so the order is not preserved. And we don't need to be concerned with it, but Python is going to store the dictionary in the way it finds most efficient. And if you need to keep track of the sequence, what would you do? You'd use a list. The list is the right structure for keeping the sequence. And as I mentioned already, the keys have to be of immutable type, whereas the value can be of any type that you like. And there are built-in operations that you can use when working with dictionary simulators. We have built-in operations for working with lists. And we have some examples here of what they look like. So you have an in, method, which allows you to is going to return a Boolean true or false if the specific key contains a specific value false. Otherwise, if you want to return the sequence of the keys, you're going to use the keys method. Values is going to return the values. there is one method called items that is actually going to return a tuple, which is something we talked about last time. This is the other type of list. It's a tuple of the key value pair. You can delete an entire entry or all of the entries, and you can use the for-in structure to loop through the dictionary. So you can probably sound somewhat familiar to what we did with lists. And here are some examples that you can do hands-on to practice working with dictionaries. I'm going to let you do this at home, okay? So let's see if there was anything else I wanted to cover. But you can take a look here how clear is going to essentially clear the dictionary and so on. And I was hoping we can do this program together. I think I'm going to let you go due to the snow, but it's interesting. The problem to be solved is, what if you have a text file and then you want to keep track of how many words appeared at what frequency and which word appeared most frequently? How would you go about it? Right? So it turns out that it would be a nice solution to actually use a dictionary, that you have a dictionary of the words, and then you can add is in an accumulator pattern one to each of the dictionary keys.
So you'd use the word you're tallying up as the key,
That's right.
and the value is the count.
That's exactly right.
Okay.
So I want to at least, let's see, maybe just take a look here. Let's see if I have the full program here. It is definitely in the book, but I just want to show you and then I'll let you go, because it's pretty cool. So I posted it here. I created, that's not it. Oh, it's a chapter 11, that's why. Okay, so if you'd like to download chapter, run it for you. I created a book with a little blurb about the towers of Hanoi, which was the other thing I wanted us to talk about. So let's take a look at that. Where did it save it? Screen share, work. All right, so I created a little text file about the Tower of Hanoi. And this was the mathematical puzzle I wanted to show you, I guess. If you want to look at it on your own, you can look at chapter 13, or we will encounter it at some point. It might be even fun to have a Byte Club meeting where we talk about hard problems in computing, do you think? If you're interested, we can create one. Okay, so in any case, there's just some random text from Wikipedia here. Well, not random, but about the Tower of Hanoi. And then we have a program, word frequency, and let's take a look. Let's run it. Magnify. All right, so I'm going to run the program. So it's going to ask what file to analyze, and it's going to be book.txt. And how many words out of the file do you want to actually have this analysis used for? So let's say 10. And then it runs, and here is the analysis. So we have the most frequent word is the, of, and so on. So this is the output. And if we look at the code here, let's see. Okay, so this is, as you know, the file to analyze is going to be, you put the file name. You can convert everything to lowercase so that it's more standard, otherwise to count capital D different than lowercase d. And then also any special character replaced with a space, so that you can then use the space to split and you guarantee that there's no period or comma or anything else. And then construct the dictionary. So this is an empty dictionary. If you just wanted to create an empty dictionary, this would be the syntax. Count is equal to empty brackets. And then for W in words, so this is the one of the methods available to a dictionary. The count of W is equal to the count of get of W and 0 plus 1. Get is another method that is going to return 0 if it's not there and 1 otherwise. So you can use this feature and then add 1 to it, right? I don't know if I showed you the get method. Let's see here.
Yeah.
Did I show it to you? Okay.
Yeah.
Exactly. And then you go through it in a loop, right, for the count in words. And then it's going to tally up the count, and then you're going to output the analysis. Count the items. The items is going to be the key value pair, sort, and then sort by frequency reverse equals true is because we want it actually from the highest to the lowest. The default would be to start with the lowest to the highest number. And then you print format with 15 and 5 blank spaces left and right justified, and you're done. And this is so, I think, so great to see how once we learn about these structures, how easy it becomes to solve problems that otherwise it would be difficult to solve, right? And this is how you use a dictionary. All right.
Is that key equals by frequency? Is that a function of Python? Or
No,
did
this
we
is we made a little frequency.
Oh, by frequency. Oh, and it returns the
function
second.
there.
I see. Okay.
Good question. So you can try this out. This is also posted under week 11. And I think that's all I have for you for tonight and for this quarter. I will be here on, see here. I'll be here on Tuesday. And I'll see you for the final, those of you coming.
It'll be remote, right?
You can take it remote if you like.
If we need to.
Yes. All right, thank you.
Thank you.
Thank you.
Learn something
See you in
again.
Java.
That's awesome.
Yeah, this one.
And
You know the standard. Look,
be safe with the snow. Sorry, yes, sir.
Yeah, very good.
this is the one we're talking about.
Yeah.